எல்லாருக்கும் வணக்கம். This is the last video in my Python series. Thank you for watching throughout this whole thing, if you've kept up with it. And this last video will be about modules and packages. So a module is any file that has certain functions coded within it that can be used in another file once it's imported into that file. So this can be any Python file. So it could even be something that you've written up. You can import that as a module into another one of your files. But there's also commonly accessible modules like the math module that I'll talk about later on. And related to that, a package is essentially a collection of modules that's organized in a sort of hierarchy so that you can access different functions within multiple modules that are within one package. And that hierarchy organization comes in use when you're talking about how to actually import it. And you can probably tell the reason why modules are so widely used and preferably used is because these are already established modules that have certain functions and processes that are commonly used within many programs, so people can use these without having to type them up again and again. So moving on to syntax, the main way to import a module is just using the import keyword import and the module name. And this essentially gives you access to any of the functions in that module, and not just the functions, but anything that's in that file, because when you import something, it runs through the entire file. So you have to make sure you don't have any, testing code or any expressions in there that you don't want to evaluate when you're importing it. And then to add on to that, there's a shorthand way to import, so you can say import module name as M. So you can use that kind of nickname. I used M to stand for module name in place of the module name when you're calling it. If your module has a long name, that can be helpful. So if you look on the right, I have just two examples of how to when you're calling, what syntax to use. So you would put the module name and use the dot notation and then the function name. And then if you're using that shorthand, you would use that whatever keyword you put as a shorthand dot function name to call whatever function you're trying to use. And then the second way is from a module, you can import just one function. So to do this, you would do from module name import function name. And in this case, you would import just that function. So when you're calling it, you only have to use that function name, which is one benefit. You don't have to use that dot notation, and you just call the function name. But also, it can sometimes not be the best because if you do that multiple times, you have just loose methods kind of laying around in your code, and you don't really know what it's associated with because you don't have that module name attached to every function, so you can't really tell what module it's coming from. So it's important to weigh both of those sides. And then the third way is I won't talk about it too much, but it's how to access a module and a function from a package. So you would do from using the package name, and then you would use the dot notation for every module that you're kind of going through. So like I mentioned before, it's like a hierarchy, so there could be modules within modules, and you would use a dot notation to go through each of those. And then you would use import and then the sub module name or a sub function name, whatever like ultimately you're trying to get to. And then to call it, again, kind of similar to the first one, you do the module name dot the function name. So now I'm just going to talk about the common modules and packages that Python uses that are helpful for different functions. So the main two are math and NumPy. These two modules are related to scientific and mathematical computations. So that's why those are the most commonly used. Some of these include dot factorial, dot pi, and those are in math. And then in NumPy, you can make arrays, so dot array. And then there's a dot linspace function, which basically it asks for two numbers and then how many numbers between that you want. So that third argument splits the range of the first two numbers by that amount. And I'll show you an example of that soon. And then there's also the pandas module, which is used for analyzing large data sets by creating data frames. So this, like we talked about in the last video, this takes files like CSV files, but it takes much larger. It can analyze much larger data sets than what I showed you last time, and it can do this because it has easier methods built into it. So you don't have to use for loops and iterate through the numerous rows and columns of data that you're trying to go through. And that's why it can be useful for that. So just some of the functions that are built into it is .median, .min, which takes the minimum, and .max, which takes the maximum value in a certain row or column. And there's a lot of other stuff related to like statistics in there. There's also .loc, and then where you put the row name inside. And there's a lot of different functions like that, which you can subset different rows and columns within the data frame using the row name and column name. And then there's also matplotlib, which is used primarily for plotting graphs, using similar capabilities to what MATLAB uses. And so this has functions like creating a x-axis label, creating a y-axis label, creating a title, and then also there's functions to create different types of graphs. So there's .scatter for scatter plots, and then .bar for bar graphs, and there's a bunch, like you can create pie charts, things like that. So you can see using a combination of these would be really useful, and for different functions as well. And I'm not going to show an example of these last two because it'll be a very long video if I do that. But definitely, if you're interested in using these, look up some documentation about it if it interests you. But I will show you an example of math and NumPy and how those functions and import statements work. So right here, I have the import math statement. So this imports the whole math module. And then if we quickly go down here, I have the two functions I'm going to show you. One function and one attribute. So the first one is the factorial function, which just takes the factorial of some of the argument. And you can see I have the module name dot, using the dot notation, and then the function name, like I mentioned before. And then here, this is used for the pi value. Since it's not a function, you don't have the parentheses, but this is another useful value if you're trying to calculate the circumference or volume of something. And then if we go back up here, I have the import statement for NumPy. So this is one case where you could create a shorthand to refer to it because NumPy is a little long to type. So usually people refer to it as NP, and so that's why you have the import NumPy as NP. And then if you go down here, so this is the example of how to create an array. So first I want to note we use this as a shorthand, and the dot, and then the array function. And so to actually create the array, it may be a little confusing here, so I'll highlight the important stuff. So this will create a 2D array. I'll show you when I print it. But to create that 2D array, you have this bracket on the outside, and then the two sets of brackets to indicate the two rows. If you wanted to create a 1D array, it would just be like that. You wouldn't need the outside brackets, but this would just be one dimensional. And then this would be 2D, and you could keep going. And then linspace, so like I mentioned, there's 3 arguments. So this will calculate 5 numbers in between 1 and 5. And you can probably guess right now what that will be. I'll run this so you can see the outputs for everything. So first one calculates the factorial of 4, which is 24, because 4 times 3 times 2 times 1 is 24. This is the value of pi. It goes pretty long, but it's not precise, but it's almost there. And then this is the 2D array, this thing. So you can see it's 2-dimensional. That first bracket is the first row, and the second bracket is the second row. And yeah, you can do a lot of things with that function. And then this linspace, just like I said, it prints out 5 numbers in between 1 and 5. So that came out easily, but we can run this again. Maybe put 10 this time. And you can see it gives 10 numbers in between 1 and 5. So that was just a really basic intro to modules and how to just import it. And, two of the most important ones, import math and import NumPy, can be used for different mathematical calculations that just normal Python doesn't have. Thank you for watching. Thanks for tuning in for these 5 videos. I had a lot of fun making them, and definitely continue to learn if any of this stuff interested you. I've listed a few resources here that may help. HackerRank is a place where you could practice Python and other languages as well. It gets you used to ways to problem solve in programming, which is a very important aspect of it. Not just knowing the language, but actually knowing how to problem solve and implement what you know. So that's a useful site to use to practice that. And then the Python Wikipedia and Codecademy are useful for just learning more about Python, and it definitely goes more into detail than what I've done. But have fun learning, and thanks for watching.